Hi all, I have already discussed about unit and dimensional formula of fundamental quantities, how to write unit and dimensional formula of various derived quantities in my second video. So now I am going to discuss about the application of dimensional analysis, which is very important. So there are three applications. Basically I will finish all the three applications in this video. So please watch this video till last. So first application, checking the correctness of a formula. कोई भी एक फार्मूला का डायमेंशनल फार्मूला मेथड से चेक कर सकते हैं whether that formula is correct or wrong. So let me give an example. This is a very famous common equation. You have studied in 9th standard also. V equal to U plus AT. What does it mean? Let me define. V is final velocity, U is initial velocity, A is acceleration, T is time. This is final velocity, this is initial velocity, this is acceleration, and this is time. So basically this is one of the famous four equations of vectors, kinematics. So in kinematics you will get this first equation and we will derive this equation in our motion videos. Anyway, I have to check the correctness of the formula, whether it is correct or not. So what I will do, I will take dimensional formula V first. So what is the dimensional formula of velocity? You know, already we have mentioned. Velocity is nothing but displacement by time. So displacement by time, and the dimensional formula is L by T. This will be L1 T minus 1. So let's say equation 1. Now what will be the dimensional formula of U? This is again same as velocity, so again L1 T minus 1. Equation 2. Now I will write the dimensional formula of A and T. A is acceleration. So acceleration is nothing but rate of change of velocity or velocity by time into time. So time will be cancelled in terms of dimensional formula. Only velocity will be there. So again it will be coming as L1 T minus 1. So from equation 1 and 2 and 3 we have observed that the dimensional formula of left hand side equal to dimensional formula of right hand side. That's why the above equation is correct. So you can write from equation 1, 2 and 3. We have observed that dimensional formula of left hand side. Left hand side is giving you velocity. Right hand side, the first term will giving you velocity. The second term, acceleration into time, is nothing but, because acceleration equal to velocity by time. So acceleration into time will be velocity. So that's why the above formula is dimensionally correct. So now I will discuss about the second application, that is derivation of a new formula. So all of you know some formula, you have remembered or you have understood or learnt, whatever. But let me consider a formula, that is centripetal force equal to mv square by r. Okay, for the time being you just imagine or assume that you do not know this formula. How centripetal force is related to mass, how centripetal force is related to velocity, and how centripetal force is related to radius. So Fc stands for centripetal force, m stands for mass, v stands for velocity, r stands for radius. Why radius? Because when a body is moving in a circular path, a centripetal force is coming into picture. So since the body is moving in a circular path, it means the circular path possesses a radius. Okay. But for the time being, just assume that you do not know what is this formula. I want to derive this formula. So let's say I don't know. But at least I know in centripetal force, mass is there, velocity is there, radius is there. But how they are present, I don't know. So what I'll do, I'll write let centripetal force is directly proportional to m to the power a. Because basically I don't know what is the value of a. Whether it is a square directly proportional to m square or inversely proportional to m square or directly proportional to m raised to half, I don't know. So that's why I am taking let Fc is proportional to m to the power a FC is proportional to V to the power B and FC is proportional to R to the power C. So combiningly FC is proportional to M to the power A, V to the power B, R to the power C, and FC is equal to, let's say, some proportionality constant K, mass to the power A, velocity to the power B, R to the power C. Equation 1. And since K is proportionality constant, so it's totally dimensionless, or dimensional formula of K is M0, L0, T0. So we are not considering the dimensional formula of K. So what I'll do, I'll write the dimensional formula of FC. So what is the dimensional formula of force? I am directly writing to save the time in this video, that is M1 L1 T minus 2. If you cannot write what is the dimensional formula of force, just go back and watch my previous videos. So M1 L1 T minus 2, mass into acceleration. Force is mass into acceleration. Mass is there for acceleration, L1 T minus 2. So this is the dimensional formula. So take it as equation 2. Now what is the dimensional formula of M to the power A? M to the power A, M stands for mass. So M stands for mass, M to the power 1 to the power A. So this will be M to the power A, equation 3. Now what will be the velocity to the power B? B to the power B. The dimensional formula of velocity is L1 T minus 1 to the power B. This will be L to the power B and T to the power minus B, because B is multiplied over here. Now equation 4. Now the last equation, R to the power C. So radius is length, L to the power 1 to the power C. This will be L to the power C, equation 5. Just observe this equation. M to the power A, mass to the power A. Velocity, dimensional formula L1 T minus 1, velocity to the power B will be L1 T minus 1 to the power B, 1 into B, B minus 1 into B minus B, L to the power B, T to the power minus B. Similarly, R to the power C is L to the power 1 to the power C, 1 into C is C, so L to the power C. So now what we will do, we will put, and for dimensional formula K, I can also write M0, L0, T0, so no need to use this. This is a dimensionless quantity. You can name it as equation 6 also. So using 2, 3, 4, 5, 6 in 1. So using 2, 3, 4, 5, 6 in 1. So I am putting a line here. I am coming from this to this. Using 2, 3, 4, 5, 6 in 1. What is my equation on FC? So what is the dimensional formula F? C M1 L1 T minus 2 equal to, what is the dimensional formula of M to the power A? That will be M to the power A. What is the dimensional formula of B to the power B? That is L to the power B, T to the power minus B. And what is the dimensional formula R to the power C, L to the power C, and K is M0, L0, T0, no need to put it. Now what I will do, M to the power 1, L to the power 1, T to the power minus 2, I will keep all M together, all L together. This is L to the power B, L to the power C. So I can take L to the power B plus C. Now last one is T to the power minus B. So this is equation 7. So now what I will do, I will compare the powers of equal bases from both sides of the above equation. Comparing power of equal bases of both sides. So in the left hand side I will get the base is M, in the right hand side I will get the base is M. But in the left hand side the power of base M is 1, whereas in the right hand side the power of base M is A. So what I will do, equating power of same bases from both sides of equation 7, I will take A equal to 1. So I will get A equal to 1. Equation 8. Because M to the power 1, okay, I am writing. Okay, M to the power 1 equal to M to the power A implies A equal to 1. Equation 8. Similarly, I can write L to the power B plus C. L to the power 1 equal to L to the power B plus C. So B plus C equal to 1. Okay, keep as it is. Now T to the power minus 2 equal to T to the power minus B. So minus B equal to minus 2. So B equal to 2. Now this is equation 9. So B equal to 2. Now B plus C equal to 1. So I will take the help of equation 9 here. Implies 2 plus C equal to 1 from equation 9. I am writing here. So C equal to 1 minus 2 implies C equal to minus 1. Equation 10. Hope all of you are clear. Very simple thing. Just I have equated the power of same basis and doing some equation solution, which is a very school technique. So we found by doing some calculation that A equal to 1, B equal to 2, C equal to minus 1. So we put equation 8, 9, 10 in equation 1. So putting 8, 9, 10 in 1, we will get FC equal to, keep that constant as K, M to the power A, that is 1, V to the power B, B is 2, B square, R to the power C minus 1. So FC equal to MV square by R. I have take K equal to 1 for convenience. So FC equal to MV square by R. So this is my desired formula. So even if you do not know whether it is square or root over, but if you know a bit, that is what are the physical quantities present in a particular derived quantity, then you can always derive a new formula. So now I will discuss the third application, that is conversion of unit between different systems. That is, I want to prove 1 Newton. I want to prove 1 Newton equal to 10 to the power 5 dyne. Before that, I want to say you something, that is Nu equal to constant, or else I can write N1 U1 equal to N2 U2. This is called principle of homogeneity. What does it mean? N stands for number, U stands for unit. If I go back to this example, 1 Newton equal to 10 to the power 5 dyne, I am trying to write something. This 1 is N1 and this Newton is U1. U1 is 1 Newton. Now this is my N2, 10 to the power 5, and this is my U2, 1 dyne. 10 to the power 5 dyne means 10 to the power 5 times 1 dyne present. 1 Newton means 1 time 1 Newton present. So since they are different system of units, that's why here N1 and here N2 are not same. N1 is not equal to N2 and also U1 is not equal to U2 because they are two different system of units. But N1 U1 equal to N2 U2, that is a constant. So N1 U1 equal to N2 U2 equal to N3 U3. But if I erase all this 1 2, then I can write Nu equal to constant. This is principle of homogeneity and I am going to use that thing in deriving these things. Convert 1 Newton. So my question is convert 1 Newton equal to 10 to the power 5 dyne. So now I want to find out 1 Newton equal to how much dyne. So take N1 equal to 1 and U1 equal to Newton, 1 Newton. N2 equal to 10 to the power 5 I have written, and you know this in your school, but I want to find it out. And U2 equal to 1 dyne. So basically I am talking about Newton and dyne. That's why Newton and dyne are nothing but the MKS system unit and CHSE system unit of force respectively. So basically I am talking about force. So in the first step you write this. In the second step you write the dimensional formula of the physical quantity involved here. So here the physical quantity is force. So dimensional formula of force is M1 L1 T minus 2. So basically I am making a comparative study between system 1 and system 2. Here N1 U1. So in this system 1, that is MKS system, my M1 mass 1 will be 1 kg. Whereas here in this system M1 is 1 gram. Because in CGS system, dyne is the CGS system unit of force. CGS, centimeter, gram, second. Now this is MKS. So my first unit is MKS, second unit is CGS. So here I have taken M1 as 1 kg. So here the system is 2. So basically I am considering this right hand side as system 2 or CGS system, system 2. Left side is MKS system or system 1. So M1 is 1 kg, here M2 will be 1 gram. Now here L1 is 1 meter because length is meter. Here L2 will be 1 centimeter because centimeter, gram, second. The system is centimeter, gram, second. Now T1 is 1 second, here T2 is 1 second. This I know. And already I mentioned from unit you can write the dimensional formula. So what is the formula? That is N1 U1 equal to N2 U2. So basically I am trying to write for N1 I am taking 1. For U1 I can take, U1 is the unit of force, and what is the dimensional formula of force? Okay, 1 Newton is not exactly equal to 1 dyne, but dimensionally they are same. Because 1 Newton contains mass, length, time in dimensional formula. 1 dyne also contains mass, length and time in dimensional formula. So since this is first system, the value is 1 here into, I am writing the dimensional formula, first system. The dimensional formula of force is M1 L1 T minus 2. So for the first system, M1 to the power 1, because this is the first system, L1 to the power 1, and this is the first system, T1 to the power minus 2. This is the first system, is equal to N2. Basically I don't know N2, equal to N2 into, this is the second system, so ML T minus 2, M1 L1 T minus 2 you can put. For second system you just put 2, 2, 2. Look, both the system possess same dimensional formula. That's why we are using dimensional analysis to convert between units. Okay. Now what I'll do, I want to find out N2, so I keep N2 here. 1 is as it is, so take all these things to this side. So M1 by M2 to the power 1. Because here M1 to the power 1, here M2 to the power 1. Here it is multiplied, now it is going to the left side. So divided. Similarly, L1 by L2 to the power 1 and T1 by T2 to the power minus 2. Hope everybody clear. Now what I'll do, I'll solve this. So implies N2 equal to, okay, what is my M1? M1 we have taken 1 kg. So put 1 kg. What is my M2? M2 we have taken 1 gram. Put 1 gram. Put square bracket. What is L1? L1 you have taken 1 meter. What is L2? L2 you have taken 1 centimeter. Put 1. What is T1? T1 you have taken 1 second. What is T2? T2 is also 1 second. So time is a physical quantity which possesses dimensional formula and unit as second, but dimensional formula is T. But it is second in both the system of units, MK system and also CHSE system. Okay, now what I'll do, N2 equal to, okay, for 1 kg, okay, now my next question, this will be cut, 1 second cut, that is not there. Now my question is, whether I'll do kg to gram or gram to kg. So since I'm going from system 1 to system 2 and my system 1 is MK system and system 2 is CHSE system, so I'll convert all the MK system to CHSE system. So in the numerator I am getting 1 kg, I can mention it 1000 gram divided by 1 gram. And for 1 meter I can mention it 100 centimeter divided by 1 centimeter. That's it. Gram cancel, centimeter cancel. Now N2 equal to 1, 2, 3, 4, 5. Now 10 to the power 5 Z2. So I got N2 is 10 to the power 5. Now I'll write the equation here. I fill the blank. 1 Newton equal to 10 to the power 5 dyne. So hope all of you have understood how we are using dimensional analysis to derive new formula, to checking the correctness of a formula and to convert units. So you can go and check your book and solve some problems. And if you have any doubt, you can ask me on the comment section of my YouTube videos. Please subscribe, watch, share and stay tuned to my video, because after this I am going to discuss error calculation and error analysis in the last video, and plenty of entrance questions are coming from the error analysis. Thank you.